Hey guys, it's Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight we've got Calculus 1 derivatives. We've just got a wide variety of derivatives we're going to do, practice our skills, and see what we can come out with. So I think you're going to like it. All right, let's get after it. All right, f of x equals x cubed minus 11x squared. Okay. Take the derivative, so we'll have f prime of x. Bring the 3 down, so 3 times x to the 3 minus 1, so 3x squared minus 2. Bring the 2 down, 2 times 11 is 22. X to the 2 minus 1, so x to the first power. So 3x squared minus 22x. Okay, 1 down. All right, this guy here, we've got 6 times x square root of x plus 3 times the cube root of x. So let's change those. F of x equals 6x to the 1/2 plus 3 times x to the 1/3, because the cube root would be noted as to the 1/3 power. All right, now f prime of x equals, bring the 1/2 times 6, x to the 1/2 minus 2 over 2, so it's 1/2 minus 1, so it gives us a negative 1/2, plus, bring the 1/3 down, 1/3 times 3, x to the 1/3 minus 3/3, so that would be 1. All right, so 6 over 2 gives us 3x to the negative 1/2 plus 3 times 1/3 is just 1, x to the negative 2/3. Okay, so we could write that as 3 over square root of x plus x, well, that'd be 1 over x to the 2/3. Okay. All right. G of t equals 2/3, or 2 over 3t squared. Well, let's rewrite this one also. 2 over 3 t to the negative 2. So g prime of t would equal negative 2, bring it down, times 2. Of course, all this is over 3. T to the negative 2 minus 1, which is negative 3. So g prime of t equals negative 4 over 3t cubed. So you'll notice we've got the negative, we bring it back down, we drop the negative. All right, f of theta equals 4 theta minus 5 sine theta. So f prime of theta equals the derivative of 4 theta. Would be just like taking the derivative of 4x. It's just 4, since we're doing this with respect to theta. So 4 minus, now we can use the constant multiple rule, pull the 5 out, take just the derivative of sine theta. So the derivative of sine theta is cosine theta. Of course, back in the day, our teacher always made us write d theta. We did the chain rule on everything. Okay. All right, so that's our first 4 out of the way. Let's see what else we've got. All right, we have f of x equals 5x squared plus 8, 5x squared plus 8 times x squared minus 4x minus 6. Now you know I'm a rules guy. We want to take the derivative of that. How do we do that? We use the product rule. Okay? And what does that product rule say? It was telling us that the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay, so the first one, 5x squared plus 8, times the derivative of the second one. So that would be 2x minus 4 plus the second one, which is x squared minus 4x minus 6, okay, times the derivative of the first one, which is going to be 10x. Okay, so that 2 came down, multiplied times 5, times x to the 2 minus 1. Derivative of a constant is 0. All right. Now let's use the FOIL method here and see if we, and then the distributive property over there, and expand this to the point we see if we can collect terms. All right, so 5x squared times 2x would be 10x cubed. Now the outside, minus 20x squared, so that's negative 4 times 5x squared, negative 20x squared. Inside, which would be 8 times 2x is 16x. And then the last, minus 32. Okay, now, let's see, I'm going to say plus. We'll just work through term by term here. 10x times x squared would be 10x cubed. 10x times negative 4x would give me minus 40x squared. And then 10x times a negative 6 would give me negative 60x. Wow, we got a bunch of terms here. Okay, I'm going to just mark through each term. I think there's only 2 cubed terms. 10x cubed plus 10x cubed is 20x cubed. Okay, I've got a negative 20x squared and negative 40x squared. So if I add those together, that's negative 60x squared. All right, let's see. Now we've got 16x minus 60x. So minus 20 would be 40 plus 4 minus 44x. Okay, that took care of these two guys. And minus 32. That's only constant, right? Okay. Well, obviously we can factor something here. What about 4? 4 times 5x cubed. 4 times 5 is 20. Minus 4 going to that 15x squared times. Minus 11x minus 8. All right, that would be f prime of x using the product rule. Hopefully the math is okay there, but you get the idea. All right, that wiped that one out. That was a good one. Better check them off. I'll end up doing the same one again. All right, we have f of x equals square root of x times sine x. Hey, another product rule, okay? So f prime of x equals the first one, well, I'll go ahead and write it as x to the 1/2, times the derivative of the second one, derivative of sine is cosine, plus the second one times the derivative of the first one, which if that were written as the first one, it would be 1/2 times x to the minus 1/2. That would be the derivative. So now I'll just list this, square root of x cosine x equals, or x, square root of x cosine x, plus I have 1/2 sine x over square root of x. So that would be x to the 1/2, negative 1/2 brought down and made to a positive. All right, that was not so bad. I'll just erase them here. Okay. Oh, here's one we need to use a different rule. X squared plus x minus 1 divided by x squared minus 1. I better grab another pen, this or marker. This one may play out before we finish that one. I'm trying to let these, turn them up where I can use them a little longer all the time. All right, so now f prime of x equals, you recall we have the bottom one squared. Okay, so now I have, it will be the bottom one, the bottom function, times the derivative of the top, which is, bring the 2 down, it'd be 2x, 2 to the 2 minus 1, plus derivative of x is 1. Derivative of the constant is 0. So the bottom one times the derivative of the top minus the top, x squared plus x minus 1, times the derivative of the function in the bottom, which would be 2x. Derivative of that constant is 0. And all of that's over the denominator squared. Oh, let's see how we can expand this. So I can FOIL this one. X squared times 2x gives me 2x cubed. Then x squared plus 1 gives me plus x squared minus 2x minus 1. Okay, minus, and I'm going to put this in parentheses till I work through and then deal with the negative. Okay, so 2x times x squared is 2x cubed plus 2x squared, and then 2x times negative 1 would be negative 2x. All right, so I need to change the sign. I want negative, minus everything in there. This would make this a negative, and that a positive, and that a negative. Okay? Now, oh, I almost forgot this. And I do this often too, for some reason, I don't know. X squared minus 1 squared. Sometimes I just forget that one. That's why I should write that down first, is what I should do. Okay, what do we have? Well, let me write that thing down first. X squared minus 1 squared. Okay, 2x cubed minus 2x cubed, those cancel. I have x squared minus 2x squared, which gives me minus 1x squared. So that goes away. Minus 2x plus 2x, that goes away. Oh, this is awesome. Minus 1. Okay, so there you have it. Of course, we could, if we wanted to, we could say, I'll factor the negative out. So negative x squared plus 1 over x squared minus 1. That should be squared. So negative x squared minus 1. There you go. So that would be using the quotient rule to be able to solve that. So we've used a product rule, we've used a quotient rule, we've used terms of bringing the exponents out of the denominator, bringing them to the numerator, working with it like that. So we've come a long way here in the tools that we're able to use. Okay, let's do another quotient. Y equals x to the 4th divided by cosine x. All right, y prime equals, I better write this denominator down first. What's in the bottom? Squared. Cosine squared x. Now then, cosine x times the derivative of the top, which would be, bring the 4 down, x to the 4 minus 1, which is 3, minus the top, x to the 4th, times the derivative of the bottom. Derivative of cosine is minus sine. So minus, I'm going to make that a plus. So a negative, negative. Okay, now then, let me just kind of clean it up a little bit. Bring this 4x cubed cosine x plus x to the 4th sine x over cosine squared x. Of course, we could factor out an x cubed. We could do that. Okay, that was the quotient rule on taking the derivative of x to the fourth over cosine x. All right, let's do another trig function here. All right, so y equals x cosine x minus sine x. Now you'll notice if I take the derivative of this side of it, I need to use the product rule to take that derivative. This one's no problem, but I have to work with this one just a little bit. All right, so it would be the first one times the derivative of the second one. Derivative of cosine is minus sine x. So I put the negative here. Plus, so first one times the derivative of the second one plus the second one times the derivative of the first one, which is just 1, minus derivative of sine is cosine x. Now you'll notice I have positive cosine x and a minus cosine x. Those subtract out. So y prime equals negative x sine x. Now in the integration, you could integrate this by parts, get back to the original function. Okay. All right. What about this one here? Y equals 3x squared times secant x. Now another product rule. Y prime equals the first one, 3x squared, times the derivative of the second one. What's the derivative of secant x? It's secant x tangent x. Secant x tangent x plus the second one, secant x, times the derivative of the first one. Bring the 2 down. 2 times 3 is 6. X to the 2 minus 1, which is just x to the first. Okay, so I've got 3x squared secant x tangent x plus 6x secant x. Now obviously we could factor secant x and 3x out of that. So other things we could do to reduce. Okay, we are rolling. All right, let's do something a little different here. Let me get a new pen while we're doing that. All right, we're going to take a function and take the derivative of it with the intent of finding the equation of the tangent line at a certain point. Okay, let's see if this is a good marker. So we've got f of x equals x plus 2 times x squared plus 5, and we want to find the equation of the tangent line at the point -1, 6. And no, that was not a good marker. Now the goal of this would be to take the derivative, and you know the slope in algebra was m. Y equals mx plus b. Okay, we're going to take the derivative of this function and then put in the point x, solve for that derivative, and that would be m, and then we're going to use the point slope formula because I have an x and a y, and get the equation of the line. That's our plan. So let's first take the derivative. F prime of x equals the first one times the derivative of the second one. Bring the 2 down. X to the 2 minus 1. Derivative of a constant is 0. Okay, plus the second one, x to the second power plus 5, times the derivative of the first one, which is just 1. So f prime of x equals 2x times x is 2x squared plus 4x plus, and this is 1 times this, x squared plus 5. So x squared plus 2x squared plus 1x squared gives me 3x squared plus 4x plus 5. And that's f prime of x. Okay, so when m, or if I'm trying to solve for, m equals f prime of x, let me put in -1. So 3 times -1 squared plus 4 times -1 plus 5. What does that equal? -1 squared is 1. 3 times 1 is 3. 4 times -1 is -4 plus 5. So 3 minus 4 gives me -1. -1 plus 5 equals 4. Okay, so m, or f prime of x, equals 4. Now, if I take y minus the point slope formula equals m times x minus x sub 1. Okay, so y minus 6 equals 4, which is my slope, times x minus a -1. Well, minus a negative is plus a positive. Okay, so now I have y minus 6 equals 4, and we just distribute the 4 inside, equals 4x plus 4. So if I add 6 to both sides, y equal 4x, 4 plus 6 is 10. So y equals 4x plus 10 would be the equation of that line, tangent line, at the point -1, 6. Now let's plug that back in. If x is -1, y should equal 6. So this 6 should equal 4 times -1 plus 10. So that's a -4 plus 10 is in fact 6. So that works out. Okay, hopefully you enjoyed this. This was just us practicing derivatives. That's all this was tonight. I tried to use quotient rule, product rule, negative exponents, the cube root of things, square root of things, and let us get used to operating with those and working along. Had a little different twist on this one, trying to find the equation of the line at a certain point. So anyway, why are we doing this? So that together we can build a better tomorrow and do that through math. Let's practice, practice, practice your math, okay? All right, guys, that's all for now, and we'll talk to you next time. Thanks.